Good day, Dr. Wan Mohammad Bukhari bin Wan Dawood. Today we are here to present our automation mini project. The title of our automation mini project is Automated Irrigation System. We are from Lab Group 5 and our teammates are Yan Tang, Jaythaan Karunaniti and me myself Subasthran Thedsinamoothy. The contents in our mini project is introduction, infographics, flowchart, logic diagram, mnemonic code, and video demonstration and conclusion. Let's start. First of all, let's start introduction. The purpose of this mini project is designing an automated irrigation system, which the system will irrigate the crop for every 8 hours. Before we see the process, let's clear ourselves. What is irrigation? Irrigation is the process of applying controlled amount of water to the plant at needed interval. Irrigation helps to grow agriculture crop, maintain landscape, and revegetate disturbed soil in dry area and during uh, periods of less than average rainfall. Irrigation also has other uses in crop production, including frost protection, suppressing weed growth in grain field, and preventing soil consolidation. In contrast, agriculture that relies on only one direct rainfall is referred to as rain-fed. Irrigation systems are also used for cooling livestock, dust suppression, disposal of sewage, and in mining. Irrigation is often studied together with drainage, which is the removal of surface and subsurface water from given area. Now let me tell you about the process flow. Once the start button is pressed, the system will judge for the necessary to irrigate crop for every 8 hours through the feedback signal from rain sensor and humidity sensor. The system will help farmers or irrigating crop on time without any manual activities. There are some requirements for this mini project. When the start button is pressed, the hour count will start counting for 8 times. Each time represent an hour. When the counters count until 8, the valve of water sprinkle will open if the humidity of soil is low. If the humidity of soil is high, the water valve will not open. Okay, now let's see infographics. This slide shows a simple animated infographic about our mini project. Let me explain about the several situations that can be seen in the infographics. First of all, when the pH value of the soil is low, fertilizer with a high pH value will be mixed with the water from the water tank and will sprinkle to the crops. However, when the pH value of soil is high, fertilizer with low pH value will be mixed with the water from the water tank and will be sprinkled to the crops. Next, when there is no rain and the soil is dry, there will be water from the for 10 minutes from the tank to the crops. When it is drizzling and the soil is still dry, there will be water flow for 5 minutes from the tank. When there is no rain and the soil is wet, there will be no water from the tank. There will be no water sprinkled from the tank. Okay. And the last situation, when it is raining and the soil is wet, there will be no water flow from the tank as well. Besides, there will be an automatically function black screen roof will close the plantation area.
My name is Yan Tang. Now I will continue to explain about the flowchart. First, when the start button is pressed, and the stop button is equal to 0, which means is at the initial condition, the hour counter will count for 8 times. Each time is equal to 1 hour. So after the hour counter is equal to 8, it will check for the humidity sensor will check for the soil humidity. If the soil humidity is dry and the rain sensor is equal to 0 means that there is no rain. The water valve will open for 10 minutes to irrigate the crops, and the hour counters will become 0 again. The hour counter will start count for next 8 hours. If the after the hour counter equal to 8, the humidity sensor it sense the soil is dry but there is raining. But there is but there is raining, so the water valve will open for only 5 minutes and the hour counter is equal to 0 will be reset to 0 again. If the humidity sensor is equal to 1, which mean the soil humidity is wet, the soil is wet, and the rain sensor is 1 means that there is raining, the roof motor will operate to cover the crops. However, if the humidity sensor sense the soil is wet and the rain sensor still sense there is no raining, the hour counter will automatically become reset to 0 and start for the next egg calculation next egg counter egg counts. Right, there is also when the humidity sensor sense the soil is wet, that means the water valve will operate, but that means it depends on the rain sensor. It will operate in 10 minutes or only 5 minutes. It depends on the whether it's raining or not. So when the humidity sensor sense the soil is wet, so the pH you will check for the pH level sensor. If the pH level sensor sense that the pH value for the soil is low, the valve with fertilizer with high pH value will open to mix the fertilizer with the water before the water is being released to irrigate the plants. Also, if the pH level sense the pH value high in the soil, the fertilizer with low pH value will open. And after that, until the water valve is closed, the process of the valve or fertilizer will also close, and it will also reset the counter to 8 times again. Right, next.
Okay. Hi, my name is Jaythaan, and I'm going to talk about logic ladder diagram for project. Okay. This will be our ladder diagram for project, which was made in CX programmer, and we'll start from rung 0. This rung includes start button and stop push button, and then it will be the output, which is the system, and this will be the background system, working system, and followed by it we'll go to rung 1, which starts with the system, and our push button, and a counter, our counter is for 8. It will count for 8 hours, because our project got a time frame which occurs, which runs the project will run every or each 8 hours. So there will be a counter for set value at #008, which indicates 8 hours, and followed by it in rung 2 it starts with system, our counter, rain sensor and humidity sensor, and water sprinkler at at 10 minutes. I'll just briefly show what is the contents of the ladder, and I'll explain to you how it works then. This will be rung 3, which has the system, how counter, rain sensor, immediate sensor, and this timer is for 5 minutes. The previous one in rung 2 will be timer for 10 minutes. And rung 4 will be the sprinkler valve, which will be triggered by the timer to open and to close. And rung 5 will be the roof motor, and rung 6 will be counter reset. and rung 7, rung 8 for fertilizer for both low pH and high pH. Okay, we'll start with how does our system works. And we have 4 conditions for our project, which is there is no rain, the soil is dry, which indicates there's no rain, which is zero state, and the soil is dry, is in zero state too. And the second condition is there's rain and the soil is dry, where the rain will be in one condition, and the soil dry will be in zero condition, which the condition is for the humidity sensor, the soil, and the rain sensor is normally as known as rain sensor. And the third condition is there's no rain but the soil is wet, which indicates the rain sensor is 0 and the soil and the humidity sensor is 1. And followed by the last condition, there's rain and also the soil is wet, which indicates the rain sensor is in one condition and the humidity sensor also in one condition. Okay, we start from the first condition where both rain sensor and humidity sensor in 0 condition, which is the initial condition. So we'll start from the hover counter. In rung 1, we'll trigger the hover push button 8 times so that it will trigger the 10-minute water sprinkler and the valves to open. And when the rain sensor and humidity sensor in 0 condition, the water sprinkler valve will open and 10 minutes and wait until 10 minutes. After the 10 minutes, all the output will be turned off and it will back to initial state. Okay, the second condition will be there's rain, which will change the rain sensor in rung 2 to become 0 state to 1 state. And as usual, we'll trigger the hover push button in rung 1 8 times. And what we observe is the timer in rung 3 will operates, where the timer for 5 minutes will trigger and the sprinkler valve will open for 5 minutes. After the 5 minutes, all the output will be turned off and it will be back to the initial state. Okay, the third condition will be, the third condition will be there's no rain and the soil is wet, which indicates the rain sensor is in, I will change the previous one, will change the rain sensor to 0 state and the humidity sensor to 1 state. So, and the output, okay, so that, and we'll trigger the hover push button in rung 1 8 times and we'll see there will be no difference, where because there's no rain and the soil is still wet, and there's no need to us to sprinkle the water. So that's the main thing. And the last one is there's rain and the soil is wet. As usual, the rain sensor and the humidity sensor will be changed to 0 state to 1 state. And so that the what there's heavy rain and the soil is wet, we can know that it is a heavy rain. So there is an output for it, where in rung 5 the roof motor will operate and it will close the rooftop of the crops. And for rung okay, and we'll go for this will be the water sprinkler part, and the next part will be the fertilizer part, where in rung 7 if the pH value sensor, it will be the sensor is tested low, we can change the low pH value push button, the switch in rung 7 to 0 state to 1 state, and the output will be the valve with filter high pH value will trigger and it will flow to the crops. And same as rung 7, rung 8, the pH value, high pH value switch will be turned on to 0 to 1, so that the value is fertilizer value, the valve with low pH value fertilizer will trigger and open and flow through the crops. For the ladder diagram, that's all. Thank you. Okay, we'll start with mnemonic code for our program. Okay, we'll start with rung 0, which is for the background system, which includes start push button and stop push button, which is LD and not. And we'll go for rung 1, and the system which will be referred to rung 1, the output of rung 1, rung 0, and the hover push button, the switch, which is N, and LD for water valve, and water valve 10 minutes and water valve 5 minutes, both LD and all push buttons. And the reset button will be OR, and there will be a counter for 8 hours, which is written there as hashtag 008, which is for 8 hours, as we assume as it's 8 hours. And then we'll go for round 2, and the system starts with this, and the line will start with system, and push button for hour counter, rain sensor, and humidity sensor. um, all three will be, hour counter will be N, rain sensor and humidity sensor will be N out, and there will be a timer there for 10 minutes, which we assume hashtag 100 will be 10 minutes for water valve. And the LD, which will be go for rung 3. All the rungs start with the systems, which is LD, the hour counter, rain sensor, and humidity sensor. All will be AND gates, and the timer will be 5 minutes for water valve, which is, we assume the hashtag 050 will be 5 minutes. And we'll go for rung 4. It starts with the system, which is LD, and followed by the hour counter, humidity sensor, water valve for 10 minutes, and water valve for 5 minutes. And also what the water valve will be the output, and 3 of it will be N not, and 1 will be hour counter will be N push button. And rung 5 will be starting with the system as usual, and they will be followed by rain sensor and humidity sensor, and the output will be roof motor. Both rain sensor and humidity sensor will be N gate and push button. And we'll go for rung 6, which as usual starts from the system, and followed by the hover counter, which is AND gate, and the humidity sensor, which is AND not push button, and low pH value will be N, which we can uh, which will be the sensor. We can change either from 0 to 1 state. And rung 7 as usual starts with system, and the hover counter will be N button, and humidity sensor N not, high pH value N, and the output will be valves with low pH value. As usual, the N gate from 38 row, high pH value, we can change the state from 0 to 1 to 1 to 0.
For part 6, there is a demonstration video of this project for the automated irrigation system. Right, first the system is walk online. The the start button is pressed, so set the value to 1. Okay. Okay. Set the value to 1, the system start operating. Since in the run 0, the system is dead in the whole circuit, so after the start button is reset to 0, so it's released, the system will still operate. Only if the stop button is pressed, the system will not operate. Right, for the first, okay. First, the rain sensor and humidity sensor is set to value 0, which means there is no raining, and also the humidity sensor sense the soil humidity. The soil humidity is dry. Right. The hour switch will represent the hour switch which will on and on each hour. So after 8 hours, the hour counters will start function. Now the first time. And the counter here will start counting down for 8 times. Alright, let's skip this. Okay, this one. Right, once the counter is on, since the rain sensor and humidity sensor is equal to 0, that means there is no rain and the soil humidity is dry. So the water sprinkler valve will start irrigate the plants, and meanwhile the timer for it will start countdown for 10 minutes. So in here it's just set to 100 seconds to quickly the process shown. So right after 100 count, the process the 100 count, the timer here will break the connection. Here break the timer connection here, and the water sprinkler will stop and the counter will reset. So this time the condition set is the rain sensor is set to 1, that means there is raining, but humidity sensor is still 0, means that the soil of the crops there is still dry. And the counter here is just the condition change is just to 1 to quickly the process, so that the switch don't have to repeatedly click on and off for 8 times. So you just click 1 times is enough to show all the process, but actually this one is for 8 times. Just change for the situation to quicken the process. The demo videos showing. Now let's start. Okay. Alright. If the rain sensor here sense 1, that means there is raining, and humidity sensor sense the soil condition is still dry, the water sprinkler valve will also open, but only for 5 minutes. Here shown is 50 seconds. Right, ear off after 50-second counts, and the counter here will reset. Now set humidity sensor to 1 and rain sensor to 0. Wait. Yes. Now set humidity sensor to 1 and rain sensor to 0. So now the humidity of the soil sand is wet, but there is no rain. So same goes. The counter will also just set to 1 first for easy showing. Okay. After it's 1, the counter will automatically reset and no process is taken. Because if the soil is wet, that means the crops does not need the water to irrigate on it. So there is no process and also there is no raining, so the roof motor will not operate to cover the rain. And the soil humidity is just enough. Alright, now last both the humidity sensor and rain sensor is equal 1. That means the soil humidity is wet and there is raining. Alright. If both these sensors sense the humidity sensor sense soil is wet and there is still raining, the roof motor will automatically operate without the hour counter counting. So the roof motor will automatically operate to cover the rain. So without waiting for the hour counter count for 8 times and it will start cover. So it will continuously cover the crops until the one of the sensor here is equal to 0. That means there is either stop raining or the humidity of the soil is dry, it's become dry. Okay. So even the counter now set to 1, so it will automatically reset. So there is no water irrigate the plants, and the roof motor will continuously block the rain. Alright, now if meanwhile the humidity sensor here wants to wait, just set to close the roof motor if either one of the rain sensor humidity sensor equal to 0. And now the water sprinkler will irrigate the crops only if the humidity sensor sense the humidity of the soil is dry. So here we use the humidity sensor as a switch to control the WAF with fertilizer high pH value and low pH value. So if the sensor we sense the soil with low pH value and the water sprinkler valve is open, so the fertilizer with high pH value will automatically mix in the water that will irrigate the crops later, and or vice versa when the high pH value is sensed, fertilizer with low pH value will be inserted to the water. First, the low pH value of the soil. Right now, right, what fertilizer high pH value will irrigate the plants until the times out is 10 minutes. The water valve close and the valve fertilizer will also close. simultaneously. Now is the high pH value. When you send high pH value, this time when 8 hours is count, right, the fertilizer below pH value will mix to the water and irrigate the crops. Yes, until 10 minutes. Yes, and stop the system. Right, that's all for the demo video of automated irrigation system.
Okay. This will be our conclusion part, which is there will be four main objectives that we achieve during our mini project, which is water usage. We can reduce the water usage while irrigating crops. And the second one will be electrical usage. The system operates for 24 hours, but it will consume much lower because it only operates for, like, the time frame is for every 8 hours. And the third one will be the farmer's job, and change the irrigate crops to operating system. It will be easier and lessen the burden for farmers, where they don't need to keep an eye every time for their crops. And the fourth and last one will be better harvest. System controls usage of fertilizer and water, which we can't see to our eyes, where the soil is in what state or in what pH value, where the system can identify it and act um, fastly before the farmers get to know that there is something problems to our crops. That's all from for the conclusion, and this will be the ending part of our mini project presentation. Thank you.